Perspective Class 10 Video 1. In this video we're going to continue talking about central projection, and we're going to do an example involving central projection. So let's begin by talking about this theorem. This theorem tells you what happens to lines under central projection. So it says that central projection sends lines to lines, or sometimes it sends lines to points. Okay? So this is very analogous to the parallel projection theorem, which reads exactly the same. Parallel projection sends lines to lines or sometimes points. The only difference is, for central projection, the type of lines that get sent to points are different. So for example, if I draw a schematic of three-dimensional space, so again the y-axis is going into the page, and I draw a plane, so this is the x equals d plane perhaps, then this line right here, this line will get sent entirely to that point. The pink line gets sent entirely to this point right here, because the pink line lies in the line of sight. Okay, it's directly the line of sight, so it gets sent to that point there. But in general, lines and line segments get sent to other lines and line segments. So let's do an example. This example says that the points -1, 0, 2, 1, 0, 2, 1, 2, 5 and -1, 2, 5 form a rectangle in three-dimensional space, and I've tried to draw a picture of what that looks like. So you've got the x-axis, y-axis, z-axis, and I've drawn the points, and I've drawn some dotted lines to highlight the fact that they form a rectangle. And what I want is for you to centrally project this onto the z equals 1 plane and sketch the result. So what this means is, like, if I try and draw a picture, which is difficult, so this is the z equals 1 plane. Okay, so what you're going to do is you're going to centrally project each of these points. So that means you draw a line from the origin to the point, you look at where it hits the red plane, and then you draw the other point. But obviously this is a complete mess and it's not very helpful, so I'm going to erase it. But geometrically that's what we're going to do. Let's just do it algebraically. Okay, so let's centrally project some of these points. The first point, -1, 0, 2, this gets mapped to, well, it's important to note that in this case we're looking at the z equals 1 plane, so this means that d equals 1. Okay, so it's going to be 1 times -1 over 2, comma 0 over 2, comma 1, which is just -1/2, 0, 1. The next point, 1, 0, 2, gets mapped to 1 over 2, 0 over 2, 1. What I'm doing is I'm dividing all of the coordinates by the z coordinate. So the z coordinate in this case is 2, so I divide all the coordinates by the z coordinate, and I times by d out front. So this is 1/2, 0, 1. The next point is 1, 2, 5. So this will get mapped to 1 over 5, 2 over 5, 1, which is just 1/5, 2/5, 1. And the last point, -1, 2, 5, is going to get mapped to 1, -1 over 5, 2 over 5, 1, which is simply -1/5, 2/5, 1. Okay, so here are the image points, and now let's try and sketch these things. So I'll draw a coordinate axis like this, and this is going to be the z equals 1 plane. So that means that this is the x and this is the y. And notice these numbers, they're really small, okay? Like they're 1/2 and 1/5 and so on. So I'm going to make my units on my coordinate axis small as well. So I'll make this 1/5, 2/5, 3/5, 4/5, 1. Minus a fifth, minus 2, minus 3, minus 4, minus 1. 1/5, 2/5, 3/5, 4/5, 1. I mean, you can make them whatever you want, right? But it's always a smart idea to choose a scale which is appropriate for the points which you're plotting. These points are very small, so I'm choosing a very fine scale. So now let's plot these points. Let's look at this first one right here. Well, I'm already on the z equals 1 plane, so ignore the 1. What I'm plotting is minus a half, comma 0. So minus a half is right there. This is minus a half, comma 0. The next one is 1/2, comma 0. So that's right here. The next one is 1/5, comma 2/5. So 1/5, comma 2/5. And the final one is minus 1/5, comma 2/5. So minus 2. Like that. And then I join up these points. Because I know that line segments get sent to line segments, I know I can join up these points. Right? I mean, I never explicitly mentioned this, but this is why the theorem up here is so useful. Telling you that line segments get sent to line segments means that if I want to work out the image of this rectangle, I don't need to work out the image of every single point individually. I just work out the image of each of the vertices and then join them up. So I work out the image of each of the vertices and then just join them up like this. Okay. So this is what the image of that rectangle looks like. And there's a bunch of things I want to point out in this example. So the first thing I want to point out is in this rectangle originally, this length right here and this length right here were the same. They're equal length, okay? They're both length 2. But after I project, one of them becomes really short and the other one is longer, okay? So in particular, this one here becomes short. The one that's further away from the eye becomes shorter. And this is something that happens with central projection. The further away an object is from the eye, from the origin, the smaller it appears, okay? So even though in real life both of these lengths are the same, under central projection, because this one was further away, it appears shorter than this one. Okay, so central projection, it distorts the length based on how far away the object is, and this is in contrast to parallel projection. In parallel projection, this wouldn't happen. Okay, the next thing I want to mention is in the original picture, this edge and this edge are parallel. They both point in exactly the same direction. Okay, but in the projected image, they're no longer parallel. Now they seem to be pointing towards each other. So originally they were parallel, but now they're not parallel. And this fact that parallel lines don't always stay parallel under central projection is going to come up a lot in some of the remaining videos. Okay. Well, that's the end of this example, and that's the end of this video.